Good afternoon to everybody. This is another lecture for the ARC 383 Introduction to the Geographical Information System. Today we are mainly trying to speak about the database and query. Therefore, I try to have a little bit, let's say, a quick lecture about the database and how database work. And then in a second part of our chapter, we are going to the ArcGIS and start to do some query job inside the ArcGIS and ArcMap. Okay, first of all, what is a database? Somehow in a first lecture, I cover and I give you some information about the data and what kind of data we have and why we need it. But in this lecture, I'm going a bit into the detail of the database. Of course, not in a database in a, let's say, comprehensive manner, because the data set itself, I think it is maybe 1 year course itself. But I'm just try to simply gather the information that you need to know. And those who wish to learn more, they could go and learn by themselves, because there are many information inside the internet and relevant book. But I try to keep it short, of course, enough for our course, not that much short, which is not understandable and not that much deep. First of all, why we need a database and how database work. If you remember, in a GIS, we need to have a data. Data is an important part of our process, almost 80%. So we need to gather this data in somewhere, because this data later, if you again remember, in a GIS definition, after we collect the data, later we call it back, we start to work on it, analyze it, and update it. Therefore, we need a database or data set, okay, in order to easily access to our data, easily could be manage those data, and easily could be update them. Okay, after access, after manage, or after update them, we are able to put some analyze on top of them and make an outcome or report for our purpose. But how data set or database could be work? I could give you a very simple database is a table. Imagine a table, just a table which includes a few column or few row, and you have always put some number on one side, for instance 1 2 3 4 5, or etc. Imagine a list of a student. So we have some column. First we have a number column, 1 2 3 4 5 up to end. Then we have a student number. Again, we put the student number, then name and surname. This is a very typical a table. Of course, you are able to store many things on it. But if you want come to the database, this number become index for us, and the column, I mean a student number, your name, and etc., called field, and those rows called record. It means that each student, it's one record. So if you have a, let's say in our course, if you have a 20 student with their information, we have 20 record. Let's give another example from your site analysis. As an architect student, you will go to the site analysis, you just watch surrounding, you have a, let's say 100 building around you. The first thing, you start to index them. You give them number. This is building number 1, this is building number 10, this is number 5, etc., etc. Sometimes building, it's have their own numeric number, so you don't need to do such a thing. Those consider as the index, but if it is totally manual and amateur job, you need to do it by your own number. So all your building becomes your record. So you have a different record. So you have one field which is index. The second field is, let's say, it could be a building type, residential type, or maybe we could say style, modern building, classic building, traditional building, etc., etc. Or we could say that land use of the building. For instance, we could say that is a residential, leisure, parking lots, governmental, etc., etc. We could give some other information such as the number of the floor. In a broad way, I want to tell you that this database, it's same as those descriptive or attribute data. If you remember, we said that GIS have a spatial data which is integrated with attribute data. So a spatial one is a point, line, and polygon, but the attribute is refer to the information of those objects, which is describe those, let's say, entity or a spatial object. Later, this data base, actually, when we have a database, we are able to easily run other application and generate a query and get the information from our database. Let's give you a very easy example of the query. What is a query? Imagine you are in the Google, you write something to search. In behind, there is a, in behind of, let's say, this Google engine, there are thousands of the table and thousands of the record. Google convert your search keyword to the query and then look into these table that which I gave you an example. This is, for instance, this is a database, very simple, schematic. Of course, it is a bit different than the table, but the concept is same. We have one index in this model or in this schematic. We just show the field, the record store inside of it. So we don't show the, let's say, record. Imagine the header of the table. We keep a header of table and just turn it to the vertical mode, and we cut the record and put it somewhere else. All these tables are linked together. Each of them connect to the other one. And each of them work with the other one. For instance, this table work with this one, with these two, and then this simple table, as you can see, work with at least 5 other tables which are connected to them. Imagine this is like I want to emphasize on this table actually. Now I want to give you another example. Imagine as a country scale in your country, and as yourself, each of you have your own table in a country scale. You have one main table which represents your name, identity, date of birth, place of birth, your ethnic, religion, gender, everything. So this is your one table, and your, of course, identity number, which is it's your index number, which is unique for you. So when you go to the, in your country, when you go to let's say police, when you go to the Ministry of Education, when you go to the bank, then they just write all your information coming out, because different authorities such as the bank, government, Ministry of Education, Ministry of the Higher Education, or police, all of them connect to your table from their own table. This is one example. Another example, maybe you will say that what's the relation to the database as to the GIS. We will see actually the relation. I'm trying to just give you right now at this moment some basic information about the database. Another things, I can give you another example. For instance, each of your computer or each of you have another database which is actually goes from your PC to your tablet, if you have a smartwatch, to your smartwatch, or if you have other smart devices, it is go to them. This table include your preference. Maybe you face with these things that I'm going to tell you right now. If you just looking into the internet in your computer and you just check for a specific things, for instance, you want to buy a clothes, a shoes, it doesn't matter, or a refrigerator, anything. Later on, you will see there are a bunch of advertisements appear in your phone in a same category from the same things. If you're looking at shoes, a bunch of shoes from a different source, from the Amazon, from eBay, from AliExpress, appear in your phone while you are moving in Instagram, Facebook. So they are spoon the relevant advertisement according to your table of preference. Your preference table, all of them is recorded there. So this is how this smart advertisement work. Now, let's come to here. Let's come to another example, which is maybe too much friendly for you. Since all of us have a portal, you have a student portal, I have a personal portal, assistant have an assistant portal, and etc. etc. All of these portal, for instance, if this is your student portal, if this is a personal portal such as an instructor, administrator, if this is a department portal, because departments also have their own portal, all of them work under the university, and each of these portals have their own table, and these tables somehow connect with each other. For instance, let's go to one of them. I'm going to the student. Under the student, you have a student number, you have a department table, you have first name, last name, you have age, gender, nationality, and your CGPA. Again, under of this, each of these table, there are a new table. For instance, department, we have a department ID. This ID like index. Here, student number is index, which means that unique. You cannot find two students with the same student number inside our university and definitely inside of any other university. And these are connect with each other. For instance, my portal connect to the department table, and my table again connect to my, let's say, this semester 9 student. So easily to be able to track. So your student again connect to your grade. So we are able to track that what is your grade, what is your attendance, what is your CGPA, what is your previous CGPA, and etc. etc. All these work with each other. Actually, it is not as simple, it is quite complex, this connection and this relation between this table. Maybe I could say that roughly, maybe it's about 1,000 of the table available inside the university. Okay, so each of them are connect with the others, or maybe 5 or 10 of them connect with one table, or etc. But to create such a things, you need to be seated from the main gate of the university up to the last gate. From the entrance, you need to check all the people, what they are doing, see, listen to their story, to understand their job in order to shape their table. Because this table should be comprehensive and gather all information. And this is actually a spiral process. You are just design the table and then go up and then go up, because every day everything become updated. So these table things also should be updated according to the new requirement inside the university. So same thing for other authority, other place, and governmental and GIS. I will have one more and two more actually a slide in order to tell you how this table could be. These are actually extra information. You don't need to memorize it. I'm just trying to provide you some extra information for those who maybe some of you wish later to go to this kind of things and create your own table for your own company, because later if you want to have a company, you definitely deal with this issue in a more detail, because you need to develop your own table. For instance, the telephone book of the customer should be related to the project of the customer that you get or you gave. The employee, the people who work with you or work with the project should be again connect all together. The account issue, the money things, all these things should be work with each other. So definitely later you will deal, if you open your own, let's say, office, or open your company, either in an architect or in other branch, you will definitely face with such a thing. So that's why I try to make it and keep it a bit bright and shiny for you. Maybe that time it's not too much become complicated for you if you have some information from now about it. Okay, we said that we have one primary, which is an index. For instance, in our university, each of the students have a unique student number. In your company, each of your customer will have a unique, let's say, index. You also, in your own country, have your own index. Your index is your identity number. Okay, this is one issue. To connect one table to another table, we need to use a foreign key. This foreign key represents the second table primary key. Okay, so these are derived from this table and come to here. So we have, when we say foreign key, it means that in this table, we could have two different students in the same time both study in architecture department, or right now here, we have two different students, Valeria and Ali, they are both studying in civil. So, but the civil, its own ID or index, it's 22. For instance, our architecture department is a 71, and our, I think, Turkish interior architecture is 78, if I'm not wrong. Okay. Now, we talk about this relation. Now we need to define the relation. So many students could be studying one department. This relation shows with this sign, with this diamond sign. Okay, so we have a many to one relation, but the other type, it is not possible. Okay, you cannot say that one student study in two departments. It is impossible. Either that person get a second student number, which that time means that two students study in two departments, or there is a definition of the double major under that department. Okay, this is about relation. I don't want to go deal with it, but this part we are coming to the query. This is the part that maybe it is better to think about it, because we will use this part in our ArcGIS. Because as you remember, I said we need to retrieve our data to get some information from our data set. We have a simple syntax. This syntax works with three important words. First, it is select. Of course, you are able to say select, update, or delete. Okay, if you update it, you will definitely update that record. You see, these are, each of them are a record. If you select, you just select it and show it or report it. If you delete it, perhaps you will delete it. You need to give some field. Which field? If you remember, I said each of these are a field. Which field you wish to select? If you put a star here, all the field will be selected. But if you specify like these two, just these two select. Now, you need to address from which table. We will say that this table is a student table. You remember I said each of this table have a name. For instance, this one is a student, this one department. Accordingly, we need to give a name. We will say that from this table, student. At end, of course, this is optional. you can get rid of it. But in order to make a limitation and in order to apply a filter, we use a condition. What is the condition? You just say that all students, show the all students, those who have those who study here have a CGPA more than 3. Accordingly, all the information become filterized. We could also give another, let's say, condition and put and with a second condition and then have a new result. We could write the same thing, but in a where we will say that the department, this field name, equal to the civil. In that time, it is just considered civil student, and after that, those whose CGPA is more than equal to, which is here. Just one thing for you here, I want to emphasize why we put civil inside the double quotation. Sometimes double quotation, sometimes single quotation in GIS actually, but in a normal data set or database like SQL server or SQL database, we use double quotation because the civil is characters. First of all, case sensitive. It means that if you are write with a small C letter, this means something else for computer, because computer cannot read what is that mean. So first of all is case sensitive. Secondly, we need to define our word, which means that we will say that our word by this quotation start from capital C letter and finish by a small l letter. We need to define it. Anywhere we use a alphabet, we will define, but for a number we don't need to define because computer understands. This is about this part. I don't want to go to the deep because this is also another method of the writing. You will define them, the syntax. For instance, you will say that the student and means S, and then you start to define. Of course, this is when we have a two table, when we want to select two different things from two different tables, we need to define that each table related to what. But I don't want to go into deep, and I want to just come to this part. This is an important part for you, for those who wants to work with GIS and especially data set. You need to know this data type. This is very important. We have actually 7 different data type. Of course, I'm just put 6 of it. In fact, we have somehow 8 data type, but still I put 6 of it because in GIS you will mainly work with these 6. And you need to keep in mind that you should work and you should need to understand why this is important and why you need to know this part. Again, you don't need to memorize it. Even I am not memorize it, this number, but be aware, because if you just Google it in internet, it is easily appear for you. But the things that here is very important, I'm emphasizing on it, very important. You need to know which data type use when and for which purpose. Okay. Otherwise, two things could be happen. First of all, your data set or database is not efficient anymore. Secondly, you will face with a different possible error in future. And somehow thirdly, which is somehow similar to the first one, which is because that one also not efficient. If you choose a wrong data type, your database become huge and enormous in terms of the size, and it is not work smoothly. This is also another important issue. So this is very important to know it. And later, if you make a mistake, it is sometimes difficult and challenging to correct those mistakes. So that's why before you start to create your data set or database in GIS or in anywhere, maybe in your future career or life, please start to design on the paper and understand the data type. Data type here is very important. Let's give you an example from those. What am I mean? For instance, if you wish, let's say, if you wish to store a small number, what could be a small number? For instance, age, 32, 35, or height, the 32,000, for instance, height. Okay. For this range, of course, from 32,000 to 32,760, for this range, minus and plus, always use short integer because the size of it is 2 bytes. And as you can see, there is no precision. You cannot say 1,000 point, let's say 986, because this just accept 1,000. If your data have a precision, you need to use other data type. If you want to store, let's say, population, okay, for a population, you are able to use this type of the data type, which is almost from 2 milliard 100 million something plus to 200 to 2 milliard 100 something million number. Okay, so with this one, which is called long integer, it is, for instance, suitable for keeping a population data or record in your database. It is, as you can see, it is 4 bytes, almost twice. Sometimes you want to keep one single precision. It means that, for instance, 2.5 or 2.9, just single precision. For this purpose, you will be able to use this float data type, which is almost, let's say, similar to the long integer occupied the space. If you want to have a big data with double precision, you are able to have actually not only double precision, maybe triple, fourth, but if your precision is more and your number also big. As you can see, this is to the power of 308 engineeringly, but this one is to the power of 38. You can imagine how big this number. So in this case, you need to choose double precision, which is occupied 8 byte. I mean that try to understand your number, how much your number are big. Accordingly, you choose this data type. It is not difficult. This is just coming from your understanding. That's all. It's very easy. And besides, you need to know that how many precision you have. If you don't have precision at all, so either you need to choose one of these two. But if you have precision, one of these float or double precision. Another thing, we have a text. Text, it is good to keep alphabet. Of course, you are able to keep a number on it. Any characters you can keep into the text. And accordingly, the size of it, it's vary. If you have too much character, the size also increase accordingly. So you need to be keep, and you need to also put a limitation always. The limitation is very important. For instance, if you want to choose a name and all your name maximum have a 20 character, let's say, you put also some safety percentages and say we have 30 character maximum. It means that 31st character not accepted, like a Twitter. After, I think, 200 or 200 something character, you cannot tweet. It is going to the next tweet. So it is a specific limitation. This is something same. And we have a date. This is a date format. For instance, you have a month, day, year, hour, minute, second, and of course, AM and PM accordingly. We have also another one, which is not here in this data table. We call it as a Boolean. For a Boolean, it is just accept either 1 or 0, on, off, close, open, like black, white, just actually two conditions, 0 or 1. This is about the Boolean, and we have a one data type. For instance, you are able to attach a picture, video, whatsoever you wish. Any other, you can able to scan, you can upload your picture, personal picture. This is about the data. Of course, we are able to do it in GIS. For instance, you are able to integrate the picture of the building. You take the building picture and you will put it inside the GIS, and then those information will be appear. This is about this part of the lecture up to this moment. Any question? I want to just come back on page. Any question right now about this part? Is it clear?
Yes, Hoca.
I want to just emphasize once more, please and please never memorize these things. Okay, just be aware. That's all. Just be, just hear that there is something available like this, and it is not become foreigner for you. And for this data type, just understand the data format. That's all. You don't need to memorize. Even I am not memorize it because I have very important things to memorize. This table is available in internet. Just if you write data type, it is coming. And for this part, just understand the concept. That's all. This is about this part of the lecture.